What do these graphs have in common? What do they actually look like when we graph them? Well, the first one we know is the y equals x squared. That one, when we graph it, is basically a parabola. What do all these other equations have in common with that? If you notice, the x is squared here. If we multiplied this out, we'd end up with x squared as a part of it. If we multiplied this out, we'd end up with x squared as a part of that. So basically in all three of these, the x part of it is squared. What does that mean for the graph? When we look at the second function, it's also a parabola. So it's kind of like the first one. The x's are squared and we end up with a parabola. For the second one, notice that the difference is that it moved to the right. The first one had a vertex at 0, 0. The second one has a vertex at 5, 0. So the whole parabola, all the points, move 5 units to the right. For the third equation, that one doesn't just move 5 to the right, it also apparently moves 3 up also. So the vertex that we have this time is now going to be 5, 3. So this is something that we can use when we talk about different ways that a parabola can look. For one, we know that the vertex is going to come from this number, the 5, and this number, the 3. Or this number, the 5, and we have nothing here, so we're going to say 0. So the vertex on this one is 5, 0. The vertex on this one is 0, 0. And if you notice, all of these parabolas where the x's are squared, they're all facing up. What do you suppose would happen if we had something like these parabolas? If you notice on all three of these, now when we look at them, all the y's are going to end up being squared or r squared. What happens when we graph those? Well, look at the first one. We still have a parabola, but now when the y is squared, it's horizontal, so it's facing the other direction. If we took that same parabola and this time changed the y value by 5, what happened? It moved up by 5. So again, if the y changes by 5, it's going to move vertically, either up or down by 5. Apparently, if it's minus, then that's going to move it up. So whereas we had 0, 0 for the vertex on this one, on the second one, we're going to end up with a vertex of 0, 5. So on the third one, what do you think the vertex is going to end up being? All right, so let's take a look at that. On this one, the y value changed by 5, so our parabola moved up 5. The x value changed by 3, so it moved 3 horizontally. So that means that our vertex is 3, 5. So basically, to get our vertex, the x part of it is going to come from where the x is. So the x part of our vertex is 3, and if we notice, we have x minus 3. The y part of our vertex is 5, and if you notice, we have y minus 5. So that's how we're going to be able to find the vertex, just by looking at the x part to get the x part of the vertex, and the y part to get the y part of the vertex, and they're always opposites. So if this says minus, then this is positive. And if this says minus, then this is positive. Let's just do an experiment just to see what would happen. If we change this minus here to a plus, what do you think would happen? That's where we would be at. And we said that this should be the opposite. This number here should be the opposite when we talk about the vertex. So if you notice, the vertex we have here has a -5 on it. So it's exactly like what we said.